We're going to do some additional notes on top of the examples that we're going to do in 5.8. So 5.8 will take us maybe 2 days to complete. There are a lot of areas that involve logarithmic and exponential functions. So, real life examples. Population growth is usually exponential. Can be represented with a formula that uses an exponential function. Compound interest, decimals, the Richter scale, pH scale in chemistry. Exponential decay shows up in bacteria decay, half-life for figuring out how old a substance is. And when you take a pill for a headache, it follows an exponential decay. And we'll learn about how the instructions on your pill box are related to that exponential decay, and why they say take 2 pills every 4 hours, and what that actually does to the drug in your body. So the first formula that we're going to look at is compound interest. And the nice thing about all of these situations is all of them have formulas. And if they put every single formula on your formula sheet, then you would have to memorize 10 formulas and what everything stood for in each of those formulas. So instead, every time they give you a question, this will happen. They'll give you the formula and they'll explain what everything stands for. You just have to know how to read the question, plug things into the formula according to what they stand for, but you won't have to memorize any of these formulas. So that is really nice. So here we have determine the final value of $500 after 10 years if it is invested at a rate of 2.25% compounded monthly. So a couple things you're going to have to know, though, is some wording stuff. Compounded monthly means 12 times a year. Compounding semi-annually means twice a year. Compounding quarterly means 4 times a year. So if we plugged everything into this one, well, you could just type this into your calculator. No logarithms are needed. We're not solving for an exponent, so we can just type it in and find the value. That's a little scary, isn't it? Projector, it's actually, I sense some excitement from you guys, like, I sure hope the projector actually crashes. You are guilty of that, I can see it. I would have been the same way as a student. I loved, this is terrible, right? But I loved it when disasters happened in classes. Like, what is the teacher going to do? The projector's about to die. Can I just turn my little screen sideways, my computer screen, and you have to look at that? All right, this one I'm actually going to skip because I can show it on the video, but it's, again, just plugging things in. One thing I have in this question, depending on your calculators, some calculators, when you write an exponent, it actually makes the numbers go up and small, and then you're not going to screw up. But other calculators sometimes have symbols like this in red where they have a little hat. And then if you don't put the 2 times 5 in brackets, your calculator will just make the 2 up as an exponent and bring the 5 down. So it's really important for all of these questions that you practice with the calculator that you're planning on using for the exam so that you know its little intricacies. But more likely, we're going to get questions like this, where it's asking you to calculate a time. And when we plug that into the equation, the time is in the exponent. So what I'm going to do here is I'm going to just get you to copy everything down. I'm going to explain it in a second. So what we would do in this question is we would divide by the 30 to get that 2 by itself. And then we can take the log of both sides, because logs solve for exponents. And then you just use your log law to bring the exponent out in front. Then the 12 and the log part you can divide to get t, and then you get the value by itself. And there's something really cool about this idea to double with interest rates. And sometimes this is called, I don't know if I have it on the slide, maybe I do. Yes, the rule of 70 or the rule of 72. And this is kind of a very, very simplistic way to get an answer to the question we just did. The rule of 70, sometimes called the rule of 72, and you can use 70 or 72, whichever makes your math easier, looks like this. If you want to find out how long it's going to take your money to double, and your interest rate in our question before was 7, which fraction looks easier if I plug in 7 to simplify? 72 over 7 or 70 over 7? 70 over 7. And if I did 70 over 7, what do I get as an answer? 10. How close was that to the actual answer that we got? Pretty good. This rule lets you figure out how long something's going to double, and it's so simple. This is the actual math that we did with the logarithms, and we got 9.93. But if you're not worried about a few decimal places and just want a ballpark, if you got 7% interest, your money would double in 10 years. If you got 8% interest, which one's easier to divide by 8? 72. 8% interest, it would double in 9 years. So you can use this as a way of figuring out how long it's going to take for your money to double. You get 5% interest, 70 divided by 5 is 14, about 14 years to double. And that's true no matter how much money you have, right? So Maxime invests $1 million, 7% interest. Grayson, $10, 7% interest. They both go back in 10 years. Maxime looks at his account. He has doubled his $1 million. He now has $2 million. Grayson also goes back. His has doubled as well. He now has $20. Which is the crazy thing about interest. Because if you can get a big enough amount of money, it's going to take the same amount of time to double as a small amount of money. Right? If you put a penny in, you go back 10 years later and be like, woo, I have 2 cents now. The key is getting that large amount of money. Right? I'm still looking for someone to be like, this is for educational purposes. I want to show my students how interest works. If someone could please borrow me $5 million for 10 years, don't worry, I will give you all back. But if I could double that in 10 years, I'd have no problem giving them $5 million back, because then I would have $5 million of my own. So knowing how interest rates work can really make you a lot of money. And especially like if you're able to, at this time, even with starting with a small amount of money, I think once you turn 18, you're able to get a tax-free savings account. And that tax-free savings account, if you invest that and it doubles, you don't pay any taxes on that investment that doubles. But if you have a bank account that pays you an interest rate, and if you have enough money in there that actually is significant, then they'll give that to the government, and the government says you have to pay some taxes on it. But if you put that money in a tax-free savings account, you won't have to pay taxes on it. And there's stories of people whose $100,000 tax-free savings account is now over millions and millions of dollars. And so they've made money within it, and it keeps making money within it, and they don't have to pay taxes. And if you can get it, however amount that you get it to is the limit that you're allowed. So if someone, like when you start, you get like $6,000 a year. So your limit is at $6,000. The next year you can add another $6,000. And they change the amount every year. So sometimes they say, oh, next year we're adding it up to $7,000. So then you would have a $13,000 maximum. But if in that $13,000 you make money in it, you increase your own maximum of how much money you can put away and make money tax-free, which is a nice thing to do because taxes are there for a reason. They have some good things to them, but for the most part, people don't like them because it costs you money, right? You don't mind them when they fix your road. You're like, oh, I like nice, smooth roads. But that's a give and take. Okay, so that is how interest rates work. And sometimes you will get this question, and they will take out this part. Well, take it out with a crayon. There we go. They will just say, calculate the time it would take for an investment to double. And you get really stuck because all of a sudden you're like, I don't know what number to put here, and I don't know what number to put here. X. $10, $1 million. It actually doesn't matter because whatever number you put here, as soon as you double it, then you simplify, you will always get 2. So if you put 10 and 20, or 5 and 10, or 3 and 6, if you simplify it, you'll always get 2. And sometimes on the exam, they'll just say, calculate the time it takes for something to double or something to triple, and they don't give you the value, and students get stuck. Well, pick any number. Just like it takes Grayson's $10, 10 years to make 20, and Maxine got $1 million in the same amount of time, seems a little bit unfair. And it is. Our system is set up so people with lots of money keep getting more money. And if you don't have very much money, you're not going to be able to take advantage of these systems and move forward. All right. 4 years ago, Andrew invested in an RSP. Interest rate was 5%. So again, we have to know where to plug things into the formula. And here, are we solving for an exponent? No. So we do not need logarithms. So the more common kind of question here, I'll put up the answer to this one, because you could just get the p by itself, plug that into your calculator. So the more typical kind of questions are the ones where they say, calculate the time. That means you have an exponent that you're solving for. And this is where we developed our skills with logarithms. I would first, well, you could do it this way. Technically, you could do it this way. I think I would divide, I'm going to just show you the way that I like it better. So I'm going to erase all of this. Your life is going to be easier if you can get the power by itself. So in this situation, I would divide both sides by 200. It's not wrong if you took the log of both sides, but if you took the log of both sides, you would have to use your product law before you could bring your exponent out in front. If we divide to get the power by itself, then we can take the log of both sides. And now when I take the log of this side, this exponent from your log law can come out in front. And we can take out our calculator. And type this in. So it's log of 5 divided by 2 over 4 log 1 plus 0.03 divided by 4. 30.657 to 3 decimal places. And all of these questions will have units. So we would look back at the original, like they would, again, our formula that I started at the beginning would tell you time was in years. So you're going to need to have years there. And just like our previous questions when solving for exponents, I would take this answer, I would store it in my calculator, and I would do a quick check. Original question had 2, 1 plus 0.03 divided by 4. Bracket to the power of 4x. If this comes out to $500, yes, then you know that you did it right. If it doesn't come out to $500, either you typed something into your calculator wrong, you did a calculation wrong, things need to be checked. Nothing's more frustrating though when you do all of your math right and then you type it actually wrong into your calculator. If you type something wrong into your calculator, surprise, your calculator will give you the wrong answer. But then when your calculator gives you the wrong answer, if you just look through your work for an hour trying to find a mistake, when there's no mistake there, the mistake was you typed it into your calculator wrong. So it's an interesting, like the grade 12 pre-calculus is an interesting beast because you have to be good at it and fairly quick to get your exam done in time. But if you go too quick, you're going to make little mistakes along the way. So it's sort of a balance of be careful. And actually, you will save yourself more time if you make sure that you're careful in every step. Every step that you do, careful that you didn't make a little mistake. Because a little mistake will cost you a lot of time. Because you'll get the answer wrong, then you'll have to redo the question. So it's better to make sure you're double checking every step along the way. So here's one. Calculate the time it would take for an investment to triple, but they don't tell you how much. So when you go to plug it in the formula, you can pick anything. I chose 1 and 3. You could pick 2 and 6, 10 and 30. It does not matter. Nice thing about picking 1 and 3 is that you don't have to divide to get the 3. So we saw with the rule of 70 that the higher the interest rate, the quicker it takes to double. Like it doubles faster if you have a higher interest rate. So investors are always looking at ways to get that value higher. So you have some money, and you want that money to make money for you for free. That's like a good plan. So you go to your bank, and they give you some options. Option one, you can put it into a GIC. Have you ever heard of a GIC? That is a guaranteed income certificate. So that means they'll say, we guarantee you 3%. Doesn't matter what else happens. You come back in a year, you get 3%. You're like, ooh, is there a way I can get a higher percentage? Well, you could invest in a stock market or a mutual fund. So you're like, ooh, this one last year gave 10%. But what's the problem with a stock market or a mutual fund? It's not guaranteed. The other one was guaranteed. You're guaranteed 3%. Stock market or a mutual fund, you could get 10%, but you could also get minus 5%. You could lose money. So now you have to make decisions. Usually stock market is better, and usually it performs higher than the guaranteed one. But you also have to be willing to lose money if that happens, because you're taking a higher risk. So a higher risk has a possibility of higher return, but also has a possibility of doing something like a stock market crash, where people lose tons and tons of money. All right, I'm going to pause the video here.